class, today we're going to be looking at multiple angle and product to sum formulas. More formulas on this sheet. I think we're going to cover the rest of them that we have not covered on this sheet today. So multiple angle and product to sum formulas. And what we're going to do first of all is list these formulas, and then we'll do a few problems using and applying the formulas. The first ones we talk about are the double angle formulas. And this is where we can break down a double angle into a single angle. So sine of 2u is 2 sine u cosine u. Cosine of 2u, it has several forms. Cosine squared u minus sine squared u is also equivalent to 2 cosine squared u minus 1. And it's also equivalent to 1 minus 2 sine squared u. So you can use either of the three to break it down to a single quantity that we want to evaluate cosine for. And tangent of 2u is 2 tangent u over 1 minus tangent squared u. Now you're probably wondering, why do I need to break these double angle down into single angles? Well, excuse me, in dealing with calculus, when you're taking integrals, you will need that as not a double u, but just as u. So this will be very helpful in calculus once you get into integration. So those are a double angle. We have power reducing. So we can break down a second power of sine by 1 minus cosine 2u over 2. We can break down a second power of cosine as 1 plus cosine 2u over 2. And we can break down a second power of tangent as 1 minus cosine 2u over 1 plus cosine 2u. Again, excuse me, you may find it helpful in calculus to break second, fourth powers down, and then notice we have double angles. You may have to then get into a single angle. Okay? We also have half angle formulas. Here, sine of u over 2 is plus or minus the square root of 1 minus cosine u over 2. Cosine u over 2 is plus or minus the square root of 1 plus cosine u over 2. And tangent u over 2 will be 1 minus cosine u over sine u, or sine u over 1 plus cosine u. So it has two forms. Should be. Are they not? No, they're not, are they? Well, I may have to make you an additional sheet. Thanks for pointing that out. We'll put that on the sheet for you. So the half angles are not on here. No, they're not. Okay. You'll have them, though. You'll have access to them. Either one of those. And we need to make a note down here. Notice you have plus and minus. The sine of sine u over 2 and cosine u over 2 depends on what? The quadrant. Okay? We know sine and cosine are negative and positive in certain quadrants, so it depends on the quadrant.
What's that first word?
Sines. Oh. Sines. Thank you. Okay, product to sum. Okay, product to sum. Sometimes, I don't know, when I'm writing, see, my mind goes faster than what I can write.
Like that should be S-I-N-S.
And sometimes I'll be writing on the board and I'll skip words too. Because I think, I'm thinking faster than what I can write. Can y'all relate? Yeah. You skip words here. I can't spell anyway. Most mathematicians can't spell. Product of sum. So we can break down a product, something like sine U, sine V. Notice here U is different from V, so two different quantities. We can break it down to the sum 1/2 cosine U minus V minus cosine U plus V. Cosine U, cosine V is 1/2 cosine U minus V plus cosine U plus V. Sine U cosine V is 1/2 sine U plus V plus sine U minus V, and cosine U sine V is 1/2 sine U plus V minus sine U minus V. Okay? Product to sum. And then lastly we have sum to product. And these are on here. Yep. We have sine X plus sine Y is 2 times the sine of X plus Y divided by 2. That's the argument of that sign. And cosine X minus Y divided by 2. So we can go from that sum to that product. We have sine X minus sine Y. It is 2 cosine X plus Y divided by 2 sine X minus Y divided by 2. And then cosine X plus cosine Y is 2 cosine X plus Y divided by 2 times cosine X minus Y divided by 2. And lastly, cosine X minus cosine Y is 2, negative 2, sine X plus Y divided by 2 times sine X minus Y divided by 2. Okay? Lots of formulas, and they're all except for the half angle, which you will have access to. They're all on this page. Now, how are we going to use these? Well, we have several problems where we will use these, and we may not use all of what we put up there today, but just in case you run across something, you will have access to them. The first problem we're going to look at will be an example of using that double angle. One of the double angle equations. So the first example, we want to find the exact solutions for sine 2x times sine x equals cosine x. Okay? We want to find the exact solutions, which means that, hey, it's going to be easier for us if we get rid of that double angle, won't it? So, what's that double angle formula? Sine 2u equals 2 what? Sine u, which is x, cosine x. Still times that sine x. So we use the double angle formula to reduce this down to a single angle. We want to get this to something that we can solve. So what I really have is 2 sine squared x cosine x, and I can subtract this cosine x. Now, how do I solve something here? Remember, I can factor by bringing out a greatest common factor. And what is my greatest common factor here? What is it? Cosine x. So I'm left with 2 sine squared x minus 1 is 0. Right? So what am I doing? I'm doing something that we learned how to do a few lessons ago, but we apply the double angle formula to break it down. So I use my factor of zero products that says cosine x is 0, or what? 2 sine squared x minus 1 is 0. So I need to solve this for sine. Sine x is plus or minus the square root of what? 1/2, which is, if we rationalize, plus or minus the square root of 2 over 2. So I need to find all values where cosine x equals 0 or sine x is plus or minus square root of 2 over 2. Now, did it give me a specific interval? No. But I think it does give you a specific interval. Let's say in the interval 0 to 2 pi. Let's put a specific interval there. Okay? So let's find out the exact solutions in that interval. So, we look back to our unit circle. Where is cosine x? 0? Pi over 2 and what? 3 pi over 2? Where is sine x plus or minus the square root of 2 over 2? Pi over 4. 3 pi over 4. 5 pi over 4 and what? 7 pi over 4. Okay? So what did we do? We used the double angle formula to break this thing down so that we could solve. And we already knew how to do this. We solved equations before, but we had to break down that double angle. Okay? Yes?
How did you get that square root of 2 over 2?
We rationalize because what is this? This is the square root of 1 over the square root of 2, right? And then we multiply both by square root of 2 over square root of 2 over the square root of 2. Okay?
Where is it between 0 and 5? So I go from...
That's a whole unit circle. But we're taking the 0 and not the 2 pi portion. Remember, 0 and 2 pi are coterminal angles. They represent the same thing, but we're taking the 0 instead of the 2 pi. So that's just one revolution around that circle. Had we not said that, we would have had to add what? Plus 2 in pi? Remember?
Yeah.
Okay. Are there other questions?
You have to check each of those? Make sure they work?
No, you don't have to check. Remember, you have to check when you square both sides or something. Other equations? Other questions. I'm saying equations. Other questions? Okay, the next we're going to look at is a power reducing formula, a problem where we're going to reduce the power. And we're going to look at the product of sum and sum to product. We told you the half angle, but I don't think we're going to have any of that. We'll still give you those formulas, but we're not going to do one today, and I don't think we have any on our upcoming test with the half angle. I think we just more so listed those for reference, but I'll give them to you anyway. So we want to use, and this one is a little bit involved, the power reducing formulas.
Will it tell you which formula to use?
This says use power reducing. This one didn't tell you though, but by seeing that double angle, you should be able to recognize. But most of them will tell you power reducing. It'll say change it from product to sum or sum to product. Okay. Use the power reducing formulas to rewrite the expression in terms of the first power of cosine. And what we want to look at is sine to the fourth power of x times cosine to the fourth power of x. Okay? So they want us to reduce this down to where we only see what? First power cosines. Okay? First power cosines. Well, let's go back over here and let's look for a minute at this power reducing stuff. Okay? I have an expression for what? My sine squared, my cosine squared. Okay? As a matter of fact, if I can get something like sine u, cosine u, I may can try to get this to just a sine. To just a sine. Let's see. Let's break this down as squares first. Let's look at sine squared x, cosine squared x. And let's look at sine squared x, cosine squared x. Same thing, isn't it? Same thing. I can use, instead of my having to apply this formula so many times, let me look at this sine 2u being what? What is that? 2 sine u, cosine u? Huh? We are, and we are going to use that. We are going to use that. But if I can somehow get this to be, and I said this was a very involved problem, okay? It is. If I could somehow get this to where I only see squares, I still see sine to the fourth in that problem. I'm just broken it down. If I look at this, if I divide both sides by 2, I have sine u, cosine u. Is that correct? Right? What happens if I square both sides here? What happens if I square both sides? I get 1/4 times sine squared 2u equals sine squared u, cosine squared u. So I can essentially replace this with that sine squared, cosine squared. Here u is x. So essentially I can go up here and say 1/4 sine squared x times 1/4 sine squared, really 2x, right? 2x, double angle, 2x. If I square both sides. And that kind of gets rid of some of those squares. Instead of having 4 squares in a problem, now I have what? 2. Okay? Now, the problem said they want this in terms of the first power of cosine. We can have double angles for cosine, but now I can break down this using my power reducing formulas. I can go ahead and do 1/4 times 1/4, which is 1/16. I can go ahead and combine those two constants there, okay? Now, sine squared 2x. Notice this says sine squared u. So that means, what is u in that problem? U is what? No, what is u? 2x, right? Sine squared u, our u over here is what? 2x. So in following that formula, I have 1 minus cosine 2 times u. If u is 2x, then what is 2 times u? 4 what? X. Here, if I let u be 2x, then 2u is what? 4x. And that is what goes in that problem over there. 1 minus cosine 2u over 2. And I have the same thing here. Hey, I'm almost there. This is already really broken down. Is it not? Kind of? Not quite? Not quite, because we're going to have another squared. We can't have that squared there. But remember, if you get it down to where you've gotten into a single power cosine, we're okay. We're not going to have that just yet. But what can I do now? I can bring out this 2 times 2. I can bring out that 1/4. Can I not? To make what? What's 4 times 16? 64. And now I can multiply this out, and I'm still going to have a cosine squared, but I can in turn get rid of it. As I said, y'all, this is probably the most involved problem we'll do today.
How about ever?
I won't lie to you like that, though. Do you want me to lie to you like that? No. No, just today. If I use 4, I have 1 minus what? 2 cosine 4x plus cosine squared 4x. But this is not to the first power of cosine because I have this squared there. So I have to use the what? Power reducing again. So what I have is 1 over 64 times 1 minus 2 cosine 4x plus. Here my u is 4x, right? And in my power reducing formula, I need 2u, which is what? 8x. So what is cosine squared u over there? It's 1 plus what? Cosine 2u, which is 8x, all over what? 2. Have I gotten this down to a first power of cosine? Yes, and I can stop right here. I can stop right there. The book, however, is not going to stop right there. But I'll take your answer stopping right here. Because we have done as the problem told us, we got rid of the square. All our cosines are to the what? First power. Question?
What does the book reduce it to? What else do they do?
Oh, they go as low as they can go. They got about 3 more steps down here.
Something like that can be on a test?
Probably not to the 4th power, maybe to a lower power. But this, I say stop it. Right at that step where you get that first power, stop it. Because what's going to happen if we continue to go? Careless errors.
I'm kind of confused. So if it was just on the 2nd power, where would we start at?
Oh, just plugging in those formulas over there, probably. Just plugging in the squared formulas. But, some of the problems in the book go on to the 6 and the 8. You won't have anything that involved. Your test will be something you can do in an hour and 15 minutes. Okay? It will be. It'll have 15 problems. How many problems did I have last time?
40.
Well, it'll have 15, but some of these problems that we did are, like that, it's kind of quick. Yes.
If you're not supposed to have power, then why didn't you stop at 1 over 16
Because we do, because when we multiply these two cosines together, we'll get a squared. Okay, y'all. That's the worst of it today. Y'all ready to go on to do something a little bit lighter and brighter?
I got a question.
Uh-huh.
When you have sine of the fourth x times cosine of the fourth x,
Mm-hmm.
could you just plug in, I'm talking like the original problem,
Mm-hmm.
could you just take your power reducing them?
You could, and you would have had 4 binomials.
Yeah. I mean,
You could have done it.
but technically I take it down to one, every cosine has one power.
No, but we're multiplying, though. We're multiplying.
Yeah.
You know? So we want to get the sum or difference here. See, he just asked, why couldn't we stop here? Because in multiplication, this would make that a square. So you want to wait till you get to these sums or differences, and that's what we have here. Sums and differences.
Could we do it that way? Like, could we-
Yeah, but you know what? It'll be more involved in the way we did it. It would be, because you have 4 binomials, essentially. Well, you can multiply out those 4 binomials, taking out all those halves. So it probably would be about the same. Probably wouldn't be anymore. But you would have what? Multiply the first 2, the second 2, and then you have 4 terms over here to multiply with 4 terms over here. So it would probably be about the same.
When you went from 1 over 16 to 1 over 64, I know you multiplied by 4.
2 and 2 here, right? We took out this 1/2. That 1/2 makes 1/4 times 1/16 is 1 over 64.
You took out 1/2.
Yeah, because we're multiplying essentially by 1/2 here. So yeah. All right, y'all ready for something a little bit lighter and brighter, as I said? Okay. All right, we'll leave up our formulas here, and we'll just work on this half of the board today, so that we can see.
They're going to be those that typical demonstration.
Your power, you will have a power reducing, but it won't be at that level of difficulty. I shouldn't be saying this on camera.
Now you study, you can go back.
We'll talk about at the end, about what'll be on there. We'll talk about it at the end. Okay?
You forget you're on camera.
I do. So I really shouldn't be mentioning what's going to be on. Because what's on, let me say this on the camera, what's on your test may not necessarily be what's on the telecourse test. Okay? So I really shouldn't mention things that are specific. So, people looking at the DVD, your test may not be necessarily what we're talking about with what will be on their test. But it'll be similar material to what we cover in class. Okay? All right. The next set of problems use the product to sum formulas to write the product as a sum or difference. So suppose we have 4 cosine power 3 sine 5 power 6. So, product to sum. Notice that it matters the order. We have cosine, then sine, okay? Not sine, then cosine. The formulas are a little different. So cosine first, then sine, so we use this formula. We still have this 4 out there, okay? But this formula says we have what? 1/2. We have what? Sine of what? The sum of those. What's power 3 plus 5 power 6? Know what that is? Have to figure out what it is. Minus what? Sine of pi over 3 minus 5 power 6. So we recognize that we had cosine first, sine second. We use this formula. So 4 times 1/2 is 2. Then we have sine. Pi over 3 plus 5 pi over 6 is 7 pi over 6. Pi over 3 minus 5 pi over 6 is negative pi over 2. Okay? Hopefully we are at a stage that we can add those things and subtract those things without questions. Can we do that? Okay. Now, I also need to remember my odd and even identities here. Okay? I need to remember them. What I have is sine 7 pi over 6. Sine is what? Odd, right? So this negative, going back to our even and odd identities, this negative here becomes positive, and it changes the sign to what? Positive. So this is plus sine pi over 2.
How does that work?
Negative sine, or sine of negative u is negative sine u. So because this is negative, it forces this to be negative, but the double negatives make what? Positive.
So all you do with that 1/2 is multiply that to 4.
Is this a little lighter and brighter than the last problem? Yeah. Okay. But essentially, that's what we're doing. We're following this formula. And you still have to remember this even and odd stuff. Okay? Even and odd. Let's look at another one with the same directions.
So that's all you have to do in the problem. You don't have to go ahead and add.
No, it just says write it as a sum or difference. Okay? The next problem, same directions. We have cosine 2 theta, cosine 4 theta. So which one are we using now? Cosine u, cosine v? Right? So this is 1/2 times what? Cosine of u minus v, 2 theta minus 4 theta is what? Negative 2 theta plus cosine of what? U plus v, which is 6 theta. Now, what do I know about cosine? I know that cosine of negative u is just cosine u because it's even. So this just becomes what? Cosine 2 theta plus cosine 6 theta. You have to follow a formula, but you have to remember what? Even and odd identities here. Okay? All right.
What about that negative?
This, because cosine is an even function, we have this identity that cosine negative u is equal to just cosine positive u. It's an even function. Question? All right, now we're going to go the other way. We want to use the sum to product formula to write as a product. So now we're going to use this stuff down here, okay? We're going to use those. So, first example, we have cosine of 120 degrees plus cosine of 30 degrees. And we want to use the sum to product formulas now. So which one are we going to look at? This one, the plus, cosine x plus cosine y, is what? 2 cosine what? What's x plus y? 120 plus 30 is 150 over 2 times cosine what? 120 minus 30 is 90 over 2, which is 2 cosine what? 75 degrees, cosine 45 degrees. And that's it. Okay. We're going to do a couple more. Now we're going to be verifying identities. We can verify identities using these formulas. Suppose we want to verify that cosine to the 4th power x minus sine to the 4th power x equals cosine 2x. Okay? Now, we want to start with the side that is most complicated. Okay? We want to start with the side that's most complicated, which is what? Cosine to the 4th power x minus sine to the 4th power x. And this is the difference of two squares, isn't it? I can factor. It's sine squared x, cosine squared x minus sine squared x, and cosine squared x plus sine squared x. What do we know about cosine squared x plus sine squared x? It's 1. So what I'm left with is cosine squared x minus sine squared x. And it tells me that I should get to cosine 2x. So is that one of my forms for cosine 2u over there? Is that one of my forms? Yes, it is, isn't it? Over here we have that cosine 2u is cosine squared u minus sine squared u. So, in all actuality, this is what? Cosine 2x. Okay? So you have to look at what you're trying to get to. Okay? One more verifying identity. Suppose we have cosine t plus cosine 3t all over sine 3t minus sine t. And we want all this stuff to equal cotangent t. So, of course, we need to work with what? The left-hand side. Okay? And we may need to use what here? What do you think we need to use? No, we won't have any half angles. But we do have sum to product, don't we? We can make those sums products because we know cotangent is like what? Cosine over sine, right? So it'll be good that we can make these some products. So let's use these here with the numerator and denominator. So the numerator, we have cosine x plus what? Cosine y? So we're going to be using what? The third one over there? It is 2 cosine, what? I need x plus y. So 1t plus 3t is what? 4t divided by 2, which is what? 2t. Do I need to write in that step? Okay, because we add these two together and divide by 2. This one. And then we have cosine of what? We subtract 1t minus 3t is negative 2t over 2. Now,
Go ahead and make that positive or cosine t.
you can, but we'll do it at the next step. What form are we going to use here? The second one, yes. Excuse me. So we have 2 what? Cosine of what? X plus y 4t over 2 times now what? Sine of our negative 2t over 2. No. X is first. 1t minus 3t is negative 2t. Huh? Mm-hmm. We're looking at this one. Oh, thank you. Mm-hmm. You are absolutely right. Thank you. Plus 2t. Thank you. So what happens here? This cancels, right? And as he said before, should we make this positive? Well, yes. It should be positive what? Cosine t, because this is an even function. And this is over sine what? T, which is what? Cotangent t.
And that becomes, that when it comes to cosine, that's even non-identical.
Uh-huh. Because it's an even function.
Doesn't sine, is sine, that's positive, okay.
Uh-huh. So it came out popular. Uh-huh.
Cos 30 is both cancel out.
Right. Same expresses in numerator and
How
denominator.
did it come out positive?
Oh.
It's t minus 3t.
What are you saying?
The sine on the, in the denominator, you have sine 2t over 2.
Uh-huh, because it's x minus y, so 3t minus 1t is 2t.
Oh, okay, I look at the numerator.
Mhm.
X and y.
Okay, are there any questions about anything that we have covered today? Okay. This will end our lesson on multiple angle and product to sum. Next time we will start a new unit. Okay, we'll start a new unit.